There is a highway in Germany where there is no speed limit, where a family sedan can legally travel at the same speed as a commercial aircraft during takeoff, where drivers routinely exceed 200 miles per hour on public roads, and somehow it is safer than most American highways. This is the Autobahn, the most legendary highway system ever built by human hands. A network so perfectly engineered that it allows unlimited speed on certain stretches while maintaining a fatality rate lower than the speed-limited highways of the United States. American engineers study it, and they cannot stop admiring it. The numbers are almost impossible to believe. The German Autobahn network stretches over 8,100 miles across the entire country. Approximately 70% of the network has no official speed limit. Drivers regularly cruise at 150 miles per hour. Some push well beyond 200. Yet Germany's highway fatality rate per mile driven is consistently lower than America's. How is that possible? How can a road with no speed limit be safer than roads where the maximum is 75 miles per hour? The answer lies not in the rules, but in the engineering. German engineering. The Autobahn was not born overnight. Its origins trace back to the 1920s, when Germany first envisioned a nationwide highway network connecting every major city. Construction began in earnest during the 1930s, and from the very first kilometer, the engineering standards were set higher than anything the world had ever seen. The original designers understood something fundamental. A road designed for high speed is not simply a wider version of a regular road. It is a completely different engineering challenge. Every curve must be banked differently. Every surface must be smoother. Every foundation must be stronger. Speed changes everything about how a road must be built. Today, the Autobahn is maintained and continuously upgraded by some of the most brilliant civil engineers on the planet. Every new section is designed using computational fluid dynamics, crash simulation software, and material science that would be familiar in aerospace engineering. This is not road construction. This is precision infrastructure science. The foundation of the Autobahn begins far beneath the surface. German engineers insist on understanding every geological detail before construction begins. Geotechnical investigations are extraordinarily thorough. Boreholes are drilled every 50 meters along proposed routes, extracting core samples that reveal every layer of soil, clay, rock, and groundwater beneath the path. The data from these investigations determines the exact foundation treatment required for each specific section. In areas with weak soil, deep stabilization columns are installed. In areas with high water tables, sophisticated drainage systems are embedded. No two sections receive identical treatment because no two sections sit on identical ground. The subgrade preparation is obsessively precise. German specifications require compaction levels that exceed those of most other countries. Vibratory rollers make multiple passes across every square meter. Plate load tests verify bearing capacity at intervals far closer together than international standards require. The Germans do not estimate, they verify. Above the compacted subgrade, a frost protection layer is installed. Germany's harsh winters subject roads to repeated freeze-thaw cycles that can destroy pavement from below. This layer, typically 300 to 500 millimeters thick, consists of specially graded non-frost susceptible material that prevents ice lens formation beneath the pavement structure. The base layers above the frost protection are where German engineering truly begins to separate itself from the world. Multiple layers of hydraulically bound material are placed and compacted. Each layer serves a specific structural purpose. Together, they create a foundation system designed to distribute loads from vehicles traveling at speeds that would terrify engineers in other countries. The concrete surface layer of the Autobahn is engineered to standards that border on obsessive. German specifications require concrete with compressive strength exceeding 50 megapascals. The mix design includes precisely graded aggregates selected not just for strength, but for surface texture, noise reduction, and resistance to polishing under millions of tire passes. The concrete is placed in 2 layers simultaneously using a specialized process called wet-on-wet paving. The bottom layer uses cost-effective aggregates for structural strength. The top layer uses premium noise-reducing exposed aggregate that provides superior grip and lower tire noise. Both layers are poured in a single pass, bonding together permanently. The surface texture of the Autobahn is specifically engineered for high-speed stability. At 200 kilometers per hour, tire behavior changes dramatically compared to normal highway speeds. The surface must provide consistent grip without generating excessive noise or spray during rain. German engineers test surface formulations in laboratories before they ever reach a real road. Drainage engineering on the Autobahn is far more advanced than standard highway design. At extreme speeds, even a thin film of water can cause catastrophic hydroplaning. The road surface is crowned with precise cross slopes that shed water within seconds. Porous asphalt layers on some sections actually absorb rainwater, preventing any surface film from forming. Beneath the road surface, an elaborate drainage network collects and channels water away from the pavement structure. Perforated pipes embedded in gravel trenches run along both sides of every section. Collection basins at regular intervals connect to underground drainage systems that prevent any water from ever reaching the foundation layers below. The geometry of every Autobahn curve is calculated using physics that accounts for vehicles traveling at speeds over 300 kilometers per hour. Superelevation, the banking of curves, is significantly steeper than on American highways. Transition spirals gradually increase the banking as drivers enter curves, preventing sudden lateral forces that could destabilize vehicles. Sight distances on the Autobahn are engineered for extreme speed. The distance a driver can see ahead must be sufficient to stop safely, even from 200 miles per hour. This requires enormous sight lines. Curves are widened, hills are flattened, vegetation is kept low. Every obstruction to forward visibility is systematically eliminated. The vertical geometry is equally precise. Hills and valleys are designed with gentle gradients that prevent vehicles from becoming airborne at high speed. Crest curves are flattened extensively so that a car traveling at 250 kilometers per hour remains firmly planted on the surface with all 4 tires maintaining contact at all times. Lane widths on the Autobahn are wider than American interstate standards. Each travel lane measures 3.75 meters compared to 3.65 meters on U.S. highways. This additional width provides critical extra space at high speed, where even small steering corrections cover more lateral distance than at normal highway speeds. The median barrier system is engineered to contain vehicles at extreme velocities. German crash barriers use a specific profile of steel and concrete designed to redirect vehicles traveling at speeds that American barriers are never tested for. Energy-absorbing end terminals prevent vehicles from penetrating the barrier and crossing into opposing traffic. Guardrails along the Autobahn are positioned and anchored to specific standards based on extensive crash testing at speeds exceeding 200 kilometers per hour. The height, profile, angle, and deformation characteristics are all calculated to minimize occupant injury during high-speed impacts. Every barrier element is an engineered safety device.
Bridge structures on the Autobahn are designed with expansion joints that remain perfectly smooth at all speeds. A bump that would be imperceptible at 60 miles per hour becomes a dangerous launching ramp at 200. Bridge deck surfaces are held to even tighter tolerances than the main roadway. Joints are continuously monitored and maintained. The pavement surface smoothness requirements for the Autobahn are among the strictest in the world. Measurements using high-speed laser profilometers verify that surface irregularities remain below thresholds established through decades of high-speed driving research. Roads that fail smoothness testing are ground down and refinished until they meet specifications. Signage on the Autobahn is designed for extreme speed recognition. Signs are larger than those on American highways. Fonts are specifically designed for readability at high velocity. Advance warning distances are significantly greater, giving drivers more time to process information and react. Even the reflective coatings are engineered for performance at extreme approach speeds. Lighting design on sections near cities uses high-intensity illumination systems that provide consistent visibility without creating glare for drivers traveling at very high speeds. In rural sections where artificial lighting is absent, the road markings themselves are engineered with premium retroreflective materials that maximize visibility under headlight illumination at any speed. The lane marking system uses a standardized pattern that communicates critical information to drivers traveling too fast to read conventional signs. Solid lines, dashed lines, and specific dash spacing patterns tell experienced drivers about upcoming conditions. This visual language is taught in German driving schools and understood instinctively by all Autobahn users. Electronic variable message signs are deployed throughout the network. These dynamic displays can change speed recommendations in real time based on current conditions. During rain, fog, or heavy traffic, temporary speed limits are activated automatically. When conditions improve, the limits are removed and unlimited speed driving resumes. The system is intelligent and responsive. The traffic management infrastructure behind the Autobahn is extraordinarily sophisticated. Over 17,000 sensors embedded in the road surface monitor traffic flow, speed, and density in real time. This data feeds into central traffic management systems that can detect congestion, accidents, and hazardous conditions within seconds of their occurrence. Automated incident detection algorithms analyze sensor data continuously. When abnormal patterns are identified, such as sudden speed reductions that indicate an accident, the system automatically activates warning signs upstream, reduces speed recommendations, and alerts emergency services. Response times are measured in minutes, not the extended delays common on American highways. Emergency refuge areas are positioned at regular intervals along the Autobahn. These pull-off zones provide safe stopping locations for vehicles experiencing mechanical problems. At extreme speeds, a tire blowout or engine failure requires immediate access to a safe stopping area. The spacing of these refuges is calculated based on the time needed to decelerate safely. The maintenance regime for the Autobahn is relentless. Surface inspections occur on cycles far more frequent than American highway maintenance schedules. Specialized vehicles equipped with laser scanning systems survey the entire network continuously, identifying surface deterioration before it becomes dangerous. Repairs are prioritized based on severity and traffic speed. Night maintenance operations are standard practice. Crews work during low traffic hours between 10 at night and 5 in the morning. Lane closures are managed with extensive advance warning systems. Crash attenuator trucks protect work zones. The goal is maintaining the road surface in perfect condition at all times, because at Autobahn speeds, imperfection means danger. The concrete used in Autobahn repairs must match the original surface characteristics exactly. Color, texture, grip coefficient, and noise properties must be identical to the surrounding pavement. Visible patches or surface inconsistencies that might be acceptable on normal highways are completely unacceptable on a road where vehicles travel at aircraft speeds. German driving education is itself a form of engineering applied to human behavior. Obtaining a German driver's license requires a minimum of 25 to 45 hours of professional instruction, including mandatory highway driving sessions. Students learn high-speed lane discipline, emergency braking at velocity, and how to assess safe passing distances at extreme speeds. The cost of obtaining a German license typically exceeds €2,000. This investment ensures that every driver on the Autobahn has been thoroughly trained in high-speed driving techniques. By comparison, most American states require minimal professional instruction and issue licenses to drivers with far less preparation for highway driving. Lane discipline on the Autobahn is strictly enforced and culturally embedded. The left lane is exclusively for passing. Drivers who linger in the left lane create dangerous situations when faster vehicles approach from behind at closing speeds that can exceed 100 miles per hour. Germans learn this discipline as a fundamental driving principle. The vehicle inspection system in Germany ensures that every car on the Autobahn is mechanically capable of high-speed operation. The TÜV inspection, conducted every 2 years, checks brakes, tires, suspension, steering, lighting, and structural integrity to standards far more rigorous than American state inspections. Unsafe vehicles are prohibited from operating. Tire requirements for German highways are specifically rated for high-speed operation. Tires must carry speed ratings matching or exceeding the vehicle's maximum capability. A tire rated for only 130 miles per hour is illegal on a vehicle capable of exceeding that speed. This ensures that every vehicle's tires can handle whatever speed the driver chooses. The combination of engineering excellence, driving training, vehicle inspection, and intelligent traffic management creates a system where unlimited speed is not reckless, but rather the natural result of meticulous preparation. Every element works together. Remove any single component and the system would fail. Together, they create something uniquely German. American highway engineers who study the Autobahn consistently express admiration for the integrated approach. The road itself is only one component. The training, the vehicles, the maintenance, the technology, and the cultural discipline all combine to create a highway system that performs at levels American infrastructure has never attempted to match. The economic impact of the Autobahn on German industry cannot be overstated. The highway network is the backbone of Europe's largest economy. German automotive manufacturers design vehicles specifically for Autobahn performance, creating a global competitive advantage. The road and the cars it carries have evolved together in a uniquely symbiotic engineering relationship. BMW, Mercedes, Porsche, and Audi all develop vehicles with the Autobahn as their primary testing ground. Features like adaptive suspension systems, carbon ceramic brakes, and aerodynamic stability packages exist specifically because drivers need them at 200+ miles per hour. The Autobahn drives automotive innovation that benefits drivers worldwide. Modern Autobahn construction incorporates environmental engineering that earlier generations never considered. Noise barriers using advanced acoustic materials protect communities near the highway. Wildlife crossings bridge the road, allowing animals to pass safely.
Rainwater treatment systems clean road runoff before it enters natural waterways. Engineering serves both speed and sustainability. The future of the Autobahn involves increasing digitalization. Vehicle-to-infrastructure communication systems will allow the road itself to communicate directly with cars, providing real-time information about conditions, hazards, and recommended speeds. Autonomous vehicles designed specifically for unlimited speed Autobahn operation are already being tested by German manufacturers. Some sections are being equipped with solar panels integrated into noise barriers, generating clean electricity while blocking
Highway noise. Inductive charging systems embedded in the road surface could eventually power electric vehicles while they drive, eliminating range anxiety on long-distance journeys. The Autobahn continues evolving as aggressively as it was originally conceived. Critics question whether unlimited speed highways remain appropriate in an era focused on climate change and fuel efficiency. Higher speeds dramatically increase fuel consumption and carbon emissions. The debate between performance and sustainability continues in Germany, with some politicians advocating for a general speed limit. So far, the engineering tradition has prevailed. Despite the debates, the Autobahn remains the gold standard of highway engineering worldwide, a system where physics, engineering, human skill, and institutional commitment combine to create something that no other country has successfully replicated. Not because others lack the money or technology, but because the Autobahn requires a complete engineering philosophy applied to every detail. Germany looked at the simple concept of a highway and asked, what if we engineered every single element to perfection? What if the road, the cars, the drivers, the maintenance, and the management systems were all designed as one integrated precision machine? The answer is the Autobahn, and the world, especially American engineers, cannot stop admiring it. What do you think about the German Autobahn? Should the United States adopt unlimited speed highways? Or is the American approach safer despite the statistics? Share your thoughts in the comments below. And if this story impressed you, hit subscribe and turn on notifications so you never miss another incredible engineering story from this channel.